Microphone has changed. Good. So are we coming in? Can everybody see in here? This. Oh, nobody's here yet. Okay. 582, right? That's this meeting. 582. Okay. Hey, Leo. All right, looks like folks are starting to trickle in. So let's go ahead and swap to the doc cam. All right. No, yes, no, yes, go. Oh, sorry, doc cam software being a little shitty. Such is life. All right. So this is, of course, MAC1105. And a few things we need to talk about. So among them, exam 3, of course. Exam 3 was last Friday. And it looks like, and I'm not sure if we have all the folks here that would ideally be here to hear this, but it looks like about half of the class was successful in getting in and completing the test, which is pretty abysmal. I don't have the names memorized, but I know that a lot of folks had various flavors of trouble. And it's unfortunate that a meaningful percentage of that came down to following directions. I don't want to sit here and berate you guys or talk down to you or anything like that. But it is incredibly important that, especially when it comes to things like this that are very procedure-based, like getting software to work or you know, mathematics, that we follow directions and pay attention to what the directions are and follow them. For the most part, the issues that I was dealing with last Friday that I was getting emails and messages on Canvas about had to do with not quite going through the procedure for HonorLock correctly, and that resulted in HonorLock not autofilling the password for you when you went into MML. I am putting together a makeup. I submitted a request for HonorLock tokens for the makeup, which is just come in at 5:30 this morning. So I think the way we're going to do this, if you weren't able to complete exam 3 last Friday, you can take makeup this. I wanted it to be today, but it's going to be this Wednesday, because I didn't get the reply with the HonorLock tokens until 5 a.m. this morning, which means I haven't had time to send those out to you. So of course we can't do it now. I sent out an email, and not a Canvas message, an email. So you need to check your Santa Fe College email, the same place you looked to get the HonorLock token on Friday, asking anybody who was unable to get into the test to reply to that email and let me know what it is that went wrong so we can fix the issues and get you into the makeup. The makeup is going to be run with honor lock exactly the same way as the test on Friday was, and the final will be run with honor lock exactly the way the test on Friday was. So if there is something that kept you from being able to get into that exam, we need to fix it. I think for most folks, it was just having trouble getting through the honor lock verification process for one reason or another. Maybe the room scan wasn't seen as sufficient, or maybe the ID scan wasn't seen as sufficient, or maybe we didn't click something that we wanted to click, and so the honor lock process didn't autocomplete. But it's critical, it's absolutely critical that we're able to get this system to work for you guys, because not only is that how the makeup will be run, so I mean, obviously you want to grade for exam 3, and for that to happen, you're going to need to get honor lock to run, but that's also how the final is going to be run, and the final is a full 25% of your grade. If you're counting on the final replacing your lower exam grade, then it's worth even more, right? Each midterm is worth about 12%, 12.5%, so that would make your final worth like 37.5% of the grade overall. That's a huge amount of the grade coming from one test. So you really don't want to lose time on the final exam to fucking around with honor lock. We want it to just work. So please check your Santa Fe email. If you weren't able to complete exam 3, reply to the email I sent you. Don't send me an extra email. Don't send me something from Gmail. Go to your Santa Fe email address or your Santa Fe email inbox. Find the email that I sent out over the weekend saying, if you had problems with the exam on Friday, reply to this, blah, blah, blah. Reply to that and let me know exactly what it is that went wrong so we can fix it. And then we will be able to move forwards. We'll have you take the makeup exam on Wednesday during class time. And hopefully that will go well, and you'll be ready to go ahead with the final. Any questions about the makeup for exam 3, how things are going to be run, or any questions to do with the honor lock stuff, anything that didn't work well for you guys last Friday that we want to talk about and figure out how to make work in this setting? Is there anything like that? Some folks also had trouble uploading their scratch work, uploading their written work to Canvas. Remember, that assignment will only accept PDFs. So you need to use a scanner app or an actual physical scanner. But just taking a click picture with your phone and sending me the HIC file or the JPEG file will not work. You need to scan it with a scanner app or an actual physical scanner and upload the PDF to Canvas. If you emailed me a JPEG or a HIC file, I saved it, but I don't want to grade that, right? The grading system works within Canvas. It organizes everything nicely by your last name. It lets me put comments in a place where you'll be able to find them, lets me annotate your work. It's the way to go. To do it any other way would be foolish. So if you were unable to get those scans in on time, you can still submit them. It'll just say you're submitting late, don't worry about it. But even if you emailed me a photo of your work, please scan the work, upload it to Canvas. That'll make life so much easier for all of us. You'll get better feedback, and it will take me much less time to grade. This grading system is already a pain in the ass. It takes forever. It takes like twice as long as grading things normally does. And if I have to go through and find each image file and relabel them with your name and make sure everything's in the right place and rotate and orient and collapse into a single thing before I can annotate, then it's only going to add to that. And I don't want that. You don't want that. So let's go ahead and just follow those directions and get it done. If you run into problems, technical problems, or a challenge or something that's not working the way you want it to, don't feel bad. Ask me for help. I'm here to help you. But please don't ignore the directions. That is difficult. Okay, any questions about the makeup exam or exam 3 stuff or the technical hurdles that might be associated with the final exam? I'm going to go ahead and pull up your syllabus here just so I can remind you. Your final exam is on the 28th at 10:30. So exam 4 will be a take-home. I'm going to give that out this Friday. The final exam will be the same sort of thing as exam 3. It will be an honor lock My Math Lab exam on the 28th. So a week from tomorrow is what I have. And it will be at 10:30 a.m. So it's not our normal time and it's not our normal day. But we're sticking to the original schedule in eSanta Fe so that this couldn't possibly conflict with other final exams. I think there is one exception to that rule. If you happen to also be in BSc 2010, Core Bio 1, that final sometimes conflicts with the college algebra final. So if you are also taking BSc 2010, Core Biology 1, talk to your teacher and make sure that they don't also have your final exam scheduled for the 28th at 10:30. If they do, the rule is that the Nat Sci department bends to the math department, so they will have an alternate testing time for you. But if you run into any trouble like that, please let me know, and we'll make sure everything works out okay. The last topic for us in this class is systems. Systems of equations and inequalities. So I'm going to go ahead and open up your last homework and your last quiz today, and I'll keep that open until the day of the final, just so you can have as much time as you want to work on it. And it has to do with these things: systems of equations and systems of inequalities. A system of equations is just a collection of equations meant to be solved simultaneously. And what I mean by that is that a solution to a system of equations will be numbers that you can plug in for the variables in every single equation, making all of them true at once. So for example, sorry, I'm working on some old paper of mine. So for example, I could take the system x plus y equals 2 and x minus y equals 0. And ask to check if the ordered pair x comma y equals 1 comma 3 is a solution. That means I would plug in 1 for x and 3 for y in both of these equations and see whether or not I get a true statement. Well, if I plug in 1 for x and 3 for y, then x plus y would be 4. Which is not true. So that ordered pair 1 comma 3 is definitely not a solution to this system. I could check if, let's say, 3 comma 3 is a solution. Well, if I plug that into equation 1, then I don't get a true statement. If I plug that into equation 2, I do get a true statement. So x minus y equals 0 becomes So remember, this is the x and this is the y. This would be 3 minus 3 equals 0, which is true. But since I want to check and see not whether this is a solution to this equation, but whether this is a solution to this whole system, I need to check and see that both equations are satisfied. So also, x plus y equals 2 becomes, what would I have? I'd have 3 plus 3 equals 2, which is not true. So neither of these points are solutions to the system. The second point satisfies the one equation, x minus y equals 0, but doesn't satisfy the first. The first point here, 1 comma 3, satisfies neither equation. And a solution to that system has to satisfy both equations at once. And we can check, this is the last one I'll do like this, if 1 comma 1 is a solution. Well, 1, so x plus y equals 2 becomes 1 plus 1 equals 2. That's true. And x minus y equals 0 becomes 1 minus 1 equals 0. That's also true. So yes, 1 comma 1 is not just a solution, but in this case, the solution, meaning there's only one of them, to the system of equations x plus y equals 2, x minus y equals 0. Because that ordered pair, that x value and that y value, right, x equals 1, y equals 1, satisfies not just this equation, not just the first equation, but satisfies both equations at the same time. So that's what it means for a point, an ordered pair, to be a solution to a system. Means that when you plug in that x value and that y value, both equations are true. In general, a system could have many equations and many variables. Here we just had 2 equations and 2 variables. But I could have had 3 or 4 equations and 5 or 6 variables. And then the solution, instead of looking like an ordered pair here, would be an ordered tuple with as many numbers as there are variables in the equations. For us, we're going to stick to 2 by 2s. In college algebra, we like to keep things simple. We're going to look at systems like this, where you've got 2 equations, each one having 2 variables. So our solutions will look like this. They will be ordered pairs. You can break systems down into 2 categories. So systems of equations can be categorized as being either linear or nonlinear, which is kind of like breaking down all the things in the world to bananas and non-bananas, but it still works. The reason we do this is because linear systems, systems of equations where all of the equations are linear, are very well understood. They're the primary object of study in the math class called linear algebra, if you've heard of that. And while it might seem like a trivial thing, it turns out to be an exceptionally deep area. The most important mathematics for high-dimensional calculus, the calculus, for example, that you use to figure out how things move through space, is all linear algebra. Nonlinear systems, these turn out to be very hard to understand. Not in the sense that we're going to play with them. You know, we'll still know what it means to find a solution. We'll understand geometrically what that means. But these are easy. These are hard. these we know everything about. These are largely undeveloped. So first, how do you recognize whether a system is nonlinear? A system of equations is linear if every equation in the system is a linear equation. And remember back from the beginning of the course, we talked about what makes an equation or a function linear or nonlinear. The stuff to look out for here is that all the variables should be raised only to the power of 1. You should never have an x squared or a y squared. And you should never have any variables under any roots or downstairs in any fractions. So an example of a linear equation in 2 variables would be something like 2x minus 6y equals 12. This is a linear equation. And any system that's built out of equations that look like this would be a linear system. On the other hand, 1 over x plus 6 times the square root of y, this would not equals, whatever, equals 5, is not linear. So this is a nonlinear equation. So even if your system has like one equation like this and one equation like this, we would still call that a nonlinear system, because a system is linear if every equation in the system is linear. So if there's one equation in the system that's not linear, then automatically the system is not linear. I want to talk to you a little bit about the picture that goes along with these things. But before I do that, any questions about this first couple little examples? So like y is 1, 1, the solution to this system, and this categorizing mechanism. So we're all comfortable with why that first equation is linear and why that second equation isn't linear. We're all comfy with why that pair 1, 1 solves the system, but why 3, 3, for example, doesn't. Okay. Let's return to the system. Let's graph. What is it? X plus y equals 2 and x minus y equals 0. So when I say I'm going to graph that system, I mean I'm going to graph both of those equations in the same xy plane. That's all. Both of those equations are linear equations, and so both of them will have graphs that are straight lines. X plus y equals 2 is the same as y equals negative x plus 2. And x minus y equals 0, that's the same as y equals x. So if I want to graph this system, I'm going to graph the line y equals x. He looks like this. Slope 1, y-intercept 0. Some points that are on here like -3, -3, 1, 1. And then the line y equals negative x plus 2, well, that has a y-intercept of 2. So here's 1, here's 2. And he has a slope of -1, so he looks like this. This is the equation x plus y equals 2. This is the equation x minus y equals 0. And the solution being the ordered pair 1, 1, we didn't solve it earlier, but we checked and saw that 1, 1 is a solution, is the point where the two lines meet. So the solution to the system is the ordered pair, right? Not one number, but a pair of numbers, a value for x and a value for y, where the two graphs intersect. And sometimes we can solve a system just by graphing. You just graph both of the lines and you try to see what that point is, where the two lines touch each other, where the two graphs touch each other. Sometimes you can read that point off really easily. Sometimes you can't read that point off really easily, right? Like if this had weird coordinates, some funny decimal number or something like that, then this might be very hard for me to find with my eyes. So graphing is one way to try to solve a system. And we have to remember that the solution to the system is the ordered pair where the graphs meet. Let's take a look at a different system. So we're going to say graph and solve. Let's do 2x plus y equals 1 and x minus y equals 0 again. Why not? So this is another linear system. Both of those equations are linear equations. And if I want to graph them, then I might put both of these lines in y equals mx plus b form like we did here to make it easier to graph. So 2x plus y equals 1 is the same as y equals negative 2x plus 1. So this will be a line whose slope is negative 2 and whose y-intercept is 1. And x minus y equals 0 is just like before. It's the same as y equals x. So if I want to graph both of these, y equals x is still looking like this guy. Slope 1 goes to the origin. And y equals negative 2x plus 1, well, he's going to have a y-intercept up here of 1 and a slope of negative 2. So he's going to look something like this. So a little bit different than the last one. This point right here is 0, 1. This point right here, of course, is 0, 0. I could come out here to like negative 4, negative 4 on that guy. Another point that's on this line, if you plug in x equals 1, then you get negative 1 out. So this is 1, negative 1. But the point I'm looking for is this one. I want to know what is that point where those two lines touch. So this is my solution. But I can't tell what it is exactly. I can't tell what the x and y values are there. I could guess that the x value is definitely like between 0 and 1, and the y value is between 0 and 1. But that's about all I can say for sure. I don't know. It's not the same as this previous guy, because this line is different than this line. Right? This line had a y-intercept of 2 and a slope of negative 1. This line has a y-intercept of 1 and a slope of negative 2. I can tell that there's a solution. I can tell that those lines do cross, but I can't tell exactly where they cross. And so the first trick that we learned for solving systems, and you might remember this from high school, is called substitution. That's where you take these equations and you solve one of them for one variable and then you plug that into the other. So for example, the second equation tells us that y is equal to x. If I substitute this in the first equation, I get, well, okay, anywhere there's a y here, I write x instead. So y equals negative 2x plus 1 becomes x equals negative 2x plus 1. Everybody see that? So my equation 2 here says y is the same as x. So if I take the equation 1 and I substitute in x for y, this equation becomes this equation, which is then having just one variable. So I can solve that. Add 2x to both sides and you get 3x equals 1. Divide both sides by 3 and you get x equals 1/3. So the x coordinate of my solution point there is 1/3. And then finally, to find the y coordinate, or the y value of the solution, we back substitute, back sub, or plug in x equals 1/3 to either equation. So it doesn't matter which equation you take this x value and plug it back into, because this point is on both lines. The easier one to work with is x minus y equals 0. So if I plugging x equals 1/3 into equation 2, we get 1/3 minus y equals 0, which is the same as saying 1/3 equals y. So that point, the solution, hence, the solution is 1/3, comma, 1/3. You could say x equals 1/3 and y equals 1/3. Or you can just write it as an ordered pair like that. How do we feel about this? Has anybody not seen substitution before? Okay. Substitution, though, is not the best way to solve these systems. May I have some clean paper here somewhere? Okay. The best way to solve a linear system is using a method called elimination. And as soon as I find some paper on which I can write, I will show you how to solve a system using elimination. So give me 1 second. trick behind solving a system using elimination is similar in spirit to the trick behind solving with substitution. Somehow you need to get rid of one of the variables. When we solved with substitution, the way we got rid of one of the variables was by solving for one of them and then plugging that in for the other. With elimination, we're going to do some sort of algebra operation that will allow us to combine the two equations in a way that one of the variables goes away. So the better method for solving linear systems is called elimination. It's called elimination because the goal is to eliminate one of the variables, i.e. to make one of the variables go away. The way you do it is you multiply through one of the equations by a non-zero constant to make that equation such that when you add it to the other equation, one of the variables goes away. And the easiest way to do this is just to show you. So let's look at x plus 2y equals -1. And how about negative 2x plus y equals 3. And I want to solve this system by elimination. Are those both going to go at the same time? No. Okay. So it's up to you which variable we want to eliminate. Here I'm going to eliminate the y's. And I'm going to do that by multiplying through equation 2 by -2 and adding it to equation 1. So I'll show you what that looks like. Here's that first step. I just multiplied through the second equation by -2. So the first equation doesn't change. It stays x plus 2y equals -1. But the second equation, I multiply everything by -2. So -2 times -2x, that's 4x. -2 times y is -2y. So I'll write that as -2y. And -2 times 3 is -6. Okay. So ignore this little stray mark here. This is -2y. Now, if I add both equations, together, I'll have x plus 4x is 5x. 2y plus -2y is 0y. And -1 plus -6 is -7. So if I add those two equations, I get this. But 0y is 0. So this is the same as just saying 5x equals -7. And that's the magic. I eliminated one of the variables. So now I just have one equation here with one variable, and I can solve that. It's an easy equation to solve. I divide both sides by 5 and get x is equal to -7/5. And just like in the substitution method, once you have one of the coordinates of the solution, either the x coordinate or the y coordinate, you can back substitute that into either equation to get the other one. So finally, we back sub x equals -7/5 into either original equation to find y. So here I'll back sub into the first equation of -7/5, because that's x, plus 2y equals -1. And I'll solve this for y. I can start by adding 7/5 to both sides. This is the same as saying 2y equals -1 plus 7/5. And I should have a common denominator over there. So -1, that's the same as -5/5. So this is the same as saying 2y equals, well, -5 plus 7, that's 2. So this is 2/5. And then finally, I divide both sides by 2. So y is equal to 2/5 divided by 2, which is the same as 2/5 times 1/2. So I keep the top alone and I multiply by the reciprocal of the bottom. The 2's cancel, and I get 1/5. Thus, the solution to the system is the ordered pair x was -7/5 and y was 1/5. And you can look at this in your calculator if you want. Actually, you know what? Let me do this in Desmos. I think you'll like the picture better in Desmos. I'm going to graph x plus 2y equals -1. That was my first equation. I'll also graph the second equation, which is -2x plus y equals 3. And we see that our solution set, oh, come here, our solution is this point right here, whose x-coordinate is -1.4, that's -7/5, and whose y-coordinate is 0.2, that's +1/5. All right, you can double check if you're not sure. -7/5, comma, 1/5, right there. So this is our solution. And it's our solution because that's the point where those two graphs intersect. That's the point where the blue graph hits the red graph. So let's come back over here. Questions about solving this system using elimination. This is the last hurdle in this class. I know everybody knows how to solve linear systems by substitution. Maybe it's been a while, maybe you would need a refresher, but I know not everybody has seen elimination before. And that is the last big thing I ask you guys to learn. All right, if you've gotten through everything so far and you're comfy with exponentials and logs, the last thing I need to see that you've learned in order to give you my stamp of approval as college algebra successful students is elimination. So questions on how we eliminated here. Okay. I would like to look at one nonlinear system with you. So linear systems always go just like this. You're going to multiply through one of the equations by some constant such that when you add the two equations, one of the variables goes away. Once one of the variables goes away, you can solve for the other guy and then back substitute to get your solution. I've been very verbose here. I've written out everything in really, really painful detail. You don't need to be this verbose when you solve the systems. I'm doing it like this because I assume for some people this is the first time they've seen this, and I want to make sure it's all super duper clear. But really this is very fast. This is much, much faster than solving by substitution. This is a nonlinear system. It's nonlinear because the first equation is nonlinear. X squared plus y squared equals 4 is nonlinear. So the system is nonlinear. All right, remember a linear system is a system where all the equations are linear. If any of the equations aren't linear, then the system is said to be nonlinear. I know what the graph of x squared plus y squared equals 4 looks like. I can show you in Desmos. It's a circle centered at the origin of radius 2. Here it is. And I can also graph the second equation, x plus y, y equals 0. It looks like that. And so this system we see appears to have two solutions. And Desmos is giving me those decimals, which are approximations for the solutions, but those are not the exact values of the solution. Oh, sorry, here we go. Let's share the whole screen. So if I graph that first equation, x squared plus y squared equals 4, that's this guy, the red circle. And the second equation, x plus y equals 0, that's this line. Desmos says that these appear to intersect right around there. If I want to find the exact values of these solution points, though, I need to solve the system. And nonlinear systems we solve by substitution. Sometimes you can eliminate in a nonlinear system, and if you can, if you want to try that, I say go ahead. But in general, elimination doesn't work for nonlinear systems. It'll work sometimes, but this is an example of a nonlinear system that could not be solved by elimination. We'd have to substitute. If I take that second equation, x plus y equals 0, and I solve it for y, I see that y is equal to negative x. Subbing this in, the first equation gives me, well, x squared is still x squared, but y squared is negative x all squared because y is equal to negative x. And 4 is just 4. Negative x squared is negative x times negative x is just x squared. So I get x squared plus x squared equals 4. X squared plus x squared is 2x squared. So I get 2x squared equals 4. And I'll continue this up here. 2x squared equals 4. That's a quadratic equation. We can solve that any mess of ways. Divide both sides by 2, and you get x squared equals 2. And then you can take square roots. Just remember that you get a plus and minus when you do that. So you get x equals plus or minus square root 2. And then we can back sub each of these into either equation to find the associated y values. Remember from our picture, it looks like there's two solutions, this solution and this solution. One of them has a negative x value and one of them has a positive x value. So when x is equal to the negative square root of 2, we get the solution. Substitute into the second equation, say negative square root of 2 plus y equals 0. That means y is equal to the positive square root of 2. So we get the solution negative root 2 comma positive root 2. That's one of the solutions. And when x is equal to the positive square root of 2, we get the solution. I plug that in, I get root 2 plus y equals 0. That means y has to be the negative square root of 2. So the other solution here is positive root 2 comma negative root 2. And those are the exact values of those 2 points. So just like we did in that first linear system example, we were able to substitute. I solved the second equation for y is equal to negative x. Then I plug that into the first equation. That gives me this quadratic, which I can solve for x. This has two solutions. X is equal to the positive square root of 2, and x is equal to the negative square root of 2. When x is equal to the negative square root of 2, y is equal to root 2, because x plus y equals 0. So I get this first ordered pair. And then when x is equal to the positive square root of 2, I plug that into x plus y equals 0, and I find that y is the negative of root 2. And I can check these. So I've got negative square root 2 comma square root 2 right there. So this is solution 1. And then I've got positive square root 2 comma negative square root 2. And this is solution 2. Right. Solution 1 and solution 2. Desmos and your graphing calculator can be useful tools for approximating solutions like this, like the negative 1.4 comma 1.4 that this showed us earlier. But we need to be comfortable going through the algebra processes to find the exact solutions. So this is where I'm going to sign off for today. Remember, if you were not able to get into exam 3, you had some sort of tech problems, you need to reply to the email I sent to your sfcollege.edu email account explaining exactly what went wrong and talk to me so we can get it fixed. Once it is fixed, we will take the makeup exam, which will be run using HonorLock the same way the original test was run. So please communicate with me. Let's get this shit taken care of, and then we will be ready for we'll be ready to move on, right? We'll be ready to continue learning about systems and get prepared for the final exam. Any questions before we sign off? Alrighty, then I hope you guys have a nice rest of your day. Remember, send me those emails or reply to that email. Don't send me something separate. Reply to the email I sent you if you need to take the makeup test. And let's get that shit fixed and sorted out so we can all move on. All right, have a wonderful day.